Good morning, everyone. Today we will discuss about the blocks of the periodic table. As we all know, in the periodic table, in the modern periodic table, there are four blocks. These blocks are S block, P block, D block, and the F block. Out of these four blocks, we will discuss about the characteristics of the S block elements in the today's lecture. So let's start today's lecture about the characteristics of the S block element. You can see here in the periodic table, there are four blocks. These first two rows, group number one, group number two, that is the S block. After that, these 10 rows, you can see group number 3 to 12, that is the D block. And here, group number 13 to 18, that is the P block. At the bottom, these two horizontal rows, that is the F block. In today's lecture, we will discuss only about these first two vertical columns that call the groups, that is a group number one and group number two, which comes in the S block element. So let's start today's lecture. Now, first of all, we will see what is the main characteristic of the S block element. The characteristic of any of thing, the first characteristic of anything is their definition, about their introduction. What we know about that S block element, what is the definition of S block element? So that is the first characteristic. So S block element are those element in which the last electron enters into the valence S subshell. You can see in case of the lithium here, the configuration is 1s2. You can see in the first shell there are two electron, electron 1, electron 2, that is the 1s raised to the power 2. Second 2s1 means in the second shell, in the S subshell of the second shell, there is only one electron. So that's the configuration of the lithium. So how can we say lithium is a S block element? Because in lithium, the last electron enters into the valence S subshell, valence 2s subshell here. So it is a S block element. So that's the definition of S block element, means the elements in which the last electron enters in the valence S subshell are called as the S block element. The S block contains two groups. These two groups are group number 1 and group number 2. Why two groups? Because in S subshell, there is only one orbital. In S subshell, there is only one orbital. And due to the presence of only one orbital, according to the Pauli exclusion principle, an orbital can have a maximum of only two electrons. Means two electrons can be placed of opposite spin in the same orbital. So due to the presence of only these two electrons, there are two groups. So in that way, we can explain about the number of group in the P block, D block, and the F block. So currently in the S block, we can see here on the basis of the fact that S subshell has only one orbital, and one orbital can have a maximum of two electrons of opposite spin according to the Pauli exclusion principle. So we can say that the S block elements include only two groups, that is the group number 1 and the group number 2. So we are just drawing here the whole periodic table. We have shown here there are the 18 vertical columns, vertical column 18, 1, 2, and up to 18, and 7 horizontal rows, 1, 2, and 7. These vertical columns called as the groups, means there are 18 groups in the modern periodic table, and there are 7 period. Horizontal rows means 7 period here. So in the group number 1, the elements are hydrogen, lithium, sodium, potassium, rubidium, cesium, and the francium. So these are the elements of the group number 1 with atomic number: hydrogen atomic number 1, lithium atomic number 3, sodium atomic number 11, potassium atomic number 19, rubidium atomic number 37, cesium atomic number 55, francium atomic number 87. How can we learn these atomic number? We have already learned about the magic number. The magic number is for the electron is 2, 8, 8, 18, 18, 32. You can see here the gap. You can see here the gap in the atomic number of hydrogen and lithium. The gap is 2. The gap is 2. Next, the gap of atomic number between lithium and sodium is 8, 3 atomic number lithium, 11 is the atomic number of sodium, so gap is 8. So the next is 11. After that, again gap of 8, 11 plus 8, 19. So atomic number of potassium is 19. After that, gap of 18, 19 plus 18, 37. So atomic number of rubidium is 37. Again, 18, 37 plus 18, 55 is the atomic number of cesium. Then 32 means 87 is the atomic number of francium. So through that magic number, we can learn the atomic number of these elements. So now what about the group number 2? In group number 2, the elements are beryllium, magnesium, calcium, strontium, barium, and the iridium. Because in group number 2, the first element is present in period number 2. There is no element which is present in first period in group number 2. So the magic number starts with 8, because in group number 1, the element is present in first period. So we can start the magic number from 2, means 1 plus 2, 3. Because there is no element in group number 2 here in the first period. So there is no element. So we'll start the magic number from 8, means beryllium, atomic number 4. After 3, lithium atomic number. The next element, beryllium, has the atomic number 4. So what is the atomic number of next? 11. After 11, that is a 12. And you can see the atomic number of beryllium is 4. So 4 plus 8, 12 is the atomic number of magnesium. After 12 plus 8, 20 is the atomic number of calcium. So 20 plus 18, 38, means 38 is the atomic number of strontium. 38 plus 18, 56, that is the atomic number of barium. And 56 plus 32, atomic number 88, that is of iridium. So in that way, we can easily learn about the atomic number of these elements of group number 1 and group number 2. Similarly, for the remaining elements in the periodic table. And we can also learn these in a particular way. There is a magic rule that we already learned in the previous lecture. Means हलीना के रबी शशि फ्रेंड, HLINA हलीना, यहां से हलीना बन गया आपका. That's the हलीना K, potassium K means K, RB रबी, C शशि, FR friend, means हलीना K, रबी शशि friend. In that way you can learn the initial of the element of these group number 1. These are the symbols. The representation of any of the element is called the symbol. The representation of atom of element is called its symbol. So these are the symbol of this element. Hydrogen symbol is H, and so on. These are the symbols. Similarly, these are the symbol of group 2 elements. In group number 2, how can we learn the name of these elements? We can learn the name of these elements, means BE से beta, MG मांगे, CA car, SR scooter, BA बाप, RA रोए. Means beta मांगे car scooter बाप रोए. Means you can learn and you can try for another such magic things to learn about these elements. You can learn in any way. I have learned these elements in direct way without that magic, but that only for you students. Next property, that about their configuration. You can see the general configuration of the element is NS1 to 2. Why NS1 to 2? Because in group number 1, you can see the elements like hydrogen, 1s1, means there is only one electron in the valence S subshell. In lithium, you can see atomic number 3, 1s2, 2s1, means in the last shell, whether that shell is first, as in case of hydrogen, or it is the second shell, as in case of lithium here, there is only one electron, and that one electron present in the S subshell, as the last electron present in the S subshell. So these are the S block element. And the valence configuration means the number of electrons remains same in the valence S subshell. In the valence S subshell of hydrogen, there is only one electron. In the lithium, there is only one electron in the valence S subshell. Means the number of electrons in the valence S subshell remains the same. So on that basis, we can say the general electronic configuration of S block in the group 1 element is NS1 for the group 1 element. And on that way, we can explain the hydrogen atom has only one unpaired electron, so it can form only one covalent bond, so their valency is also one. In that way, we can also explain about their valency. Valency means the bond formation capacity of an atom of element. So the hydrogen can form only one bond due to the presence of that one electron in their valence shell. You can also see about the number of electron in the valence shell of the remaining group 1 element. After hydrogen and lithium, the next element is sodium, atomic number 11, 1s2, 2s2, 2p6, 3s1. Means in the valence shell is 3, and in the valence S subshell there is also one electron. Potassium 1s2, 2s2, 2p6, 3s2, 3p6, 4s1. You can see here also the valence shell is 4, means the number of shells goes on increasing on moving down the group, but the number of electron in the valence shell remains the same, that is only one electron. Similarly, for the rubidium and cesium, you just increase one number, 4s1 in place of 4s1 means 5s1 for the rubidium and the 6s1 for the cesium. So that about their configuration of the group 1 element. Similarly, we can say about the configuration of the group 2 elements. In the group 2, the first element is the beryllium. So configuration is 1s2, 2s2. Means you can see here the number of electron in the valence S subshell is 2. So the general configuration for the S block element is ns1, 1 for the group 1 element, 2 means 2 for the group 2 elements. So the general configuration of the S block element is ns1, 2, 2. So 1 for group 1 elements and number of electron 2 for the group 2 elements. So the general configuration here is ns1 to 2. You can see here for the beryllium, the configuration atomic number 4, the configuration is 1s2, 2s2. And that's here is the diagram. That is the nucleus where the proton neutrons are present. In the first shell, you can see in the first shell, there are 2 electrons are present, these 1s2, these 1s2 electrons. Second 2s2, these electrons are present in the second shell, and the orbital are of S subshell, 1 orbital, and P subshell is vacant here. So in case of beryllium, the P subshell is vacant. So beryllium has 2 unpaired electron in their valence shell, 2 unpaired, 2. How the here the 2 electron present in the paired state means these 2 paired electron can be unpaired due to the very less energy gap between the that second 2s and the 2p. Second shell has S and P subshell, very less energy gap between these S and P, so that 2s paired electron can be unpaired due to the less energy gap by providing only very slight amount of energy. So beryllium can have a maximum of 2 unpaired electron. So due to the presence of 2 unpaired electron, their valency is 2. It can form 2 bond. It can form 2 bond. Similarly, we can see the electronic configuration of these remaining element after beryllium. The next element is magnesium, atomic number 12. Just increase the number of shell. In case of beryllium, the valence shell is 2s, electrons are 2, 2s2. For magnesium, that is the 3s2. For calcium, for the next element in that succession of group number 2, for the calcium, the valence configuration is 4s2. In examiner can ask question like that, what is write only the valence configuration. Valence means you can't write the inner shell or the subshell, just write the outer one. You can write these in the rough work and then write only the valence one. Means what asked by the examiner, you have to write only that point, not the excess one. So the valence configuration for the calcium is 4s2. The valence configuration for the strontium is 5s2. Similarly, for the next element, barium, the valence configuration is 6s2. Means what's going on? Means on moving down the group in whether the group 1 element or the group 2 or any other, the number of shell increases. On moving down the group, the number of shell increases. So that's the basic fact you have to learn here. What is the next property of the S block element? After seeing the definition of the S block element or the valence configuration, next point, after seeing the valence configuration, as you see in the S block element, there is only 1 electron in the valence shell. And after losing that 1 electron, means everyone you have already learned that the stablest group in the periodic table is group number 18. Group number 18 means helium, neon, argon, krypton, xenon, radon. These are the group 18 elements. They have the fulfilled stable configuration. Every element want to achieve that fulfilled stable configuration like the group number 18. So all element want to get stabilized. All elements want to achieve that valence shell configuration like that of the group number 18. So how that lithium, that is the group 1 element, achieve the configuration like the group number 18, which is the nearest element, for the lithium. The nearest element for the lithium is after losing one electron, their configuration become like that of the helium after losing one electron. But after gaining how many electron? 3 plus 7. After gaining 7 electron, it becomes like that of the neon, atomic number 10. So what is the easy possible way? Easy possible way is just to lose the electron, not to gain the 7 electron. So the lithium want to lose 1 electron. They have the ability readily lose 1 electron, want to lose 1 electron. So the S block element of group number 1, they have the ability to lose 1 electron to acquire group 18 like configuration. Means after losing 1 electron, they will acquire +1 charge. So they can show the +1 oxidation state. They can form unipositive ions. So that is the next characteristic of the S block element about the group number 1. You can see through that diagram also, that is the one unpaired electron which can be lost easily, and after losing that electron, the remaining part is that one, means helium like configuration. Similarly, the group number 2 elements can lose 2 electrons because there are 2 electrons in their valence shell. Like you can see here in case of the beryllium, the configuration is 1s2 2s2 because atomic number is 4. So there are 2 electrons in their valence shell. These 2 electrons can be lost easily because after losing these 2 electrons, the dipositive ion will be formed, and that dipositive ion configuration will be like that of the helium. So it becomes more stabilized. So the group number 2 element can readily lose 2 electrons and can form dipositive ions, means +2 ions, means they can show the +2 oxidation state. In examination, examiner can ask why group 1 element can show +1 oxidation state. So you will simply write the group 1 in the group 1 elements, there is only 1 electron in their valence shell which can be lost easily, and after losing that 1 electron, they acquires the group 18 like configuration. So they can show the +1 oxidation state. Similarly, when an examiner asks why the group 2 element shows the +2 oxidation state, what you will write? You will simply write the valence in the valence shell of the group 2 element, there are 2 electrons which can readily be lost, which can easily be lost, and after losing these 2 electrons, the group 2 element acquires the group 18 like configuration, group 18 like fulfilled stable configuration. So they can easily lose 2 electrons, so they can show the +2 oxidation state. So that's the way to write the answer and also draw that particular diagram. You must have to draw that diagram. For group 1, you can draw that particular diagram. For group 2, you can draw that one diagram. So these are the diagram both for group number 1 and group number 2. So that's the next characteristic of the S block element, means they can show +1 and the +2 oxidation state, +1 for the group 1 element and +2 for the group 2 elements. Next, they have the low ionization energy. Low ionization energy means the amount of the energy required, means as we all know, the nucleus has the positive charge, and there is that valence electron, means that electron has the negative charge. So there is something attraction between the nucleus and that valence electron. Due to that particular attraction, these valence electron are strongly attracted towards the nucleus. So these electron cannot be easily lost. For losing these electron, we require some amount of energy. So that amount of energy which is required to remove that valence shell electron, but there is a condition. Condition is that particular atom must present in the isolated form, must present in the gaseous state. So before providing the energy, means the other amount of energy which is required to convert that solid lithium into the gaseous state, that is not the ionization energy, because that energy is required for the conversion of state, means solid state to gaseous state, that is the heat of sublimation. उसे आप heat of sublimation कहेंगे, not the ionization energy. Ionization energy word can only be used when you have an atom. Atom means we are calling it atom. It means it is in isolated state, it is alone. Further, it must be present in the gaseous state. That atom must be present in the gaseous state. For that gaseous state, what amount of energy is we are providing it to remove that valence electron? Now that energy is called ionization energy. So means that is the definition of ionization energy. Means the amount of energy which is required, to remove that valence shell electron from the isolated gaseous atom. That is the ionization energy. Assume that that particular lithium is present in the gaseous state. We have already converted into the gaseous state. Now what we are providing here, what amount of energies we are required to remove that valence electron from that isolated gaseous atom, that called the ionization energy. Because that energy will be very low. Why that energy will be very low? Because if after losing that electron, that particular atom going to stabilize like that of the group 18 element, so that lithium want to move towards that particular state, want to lose that particular electron, because after losing one electron it become more stabilized like the group number 18. So very less amount of energy is required to remove that valence electron from the isolated gaseous atom of that lithium. Similarly, in case of the beryllium, you can see the conjugation is 1s2 2s2. These two valence electron can be lost easily from that isolated gaseous atom, because after losing these two electron it acquires the group 18 like stable configuration, fulfilled stable configuration. So very less amount of energy is required to remove the electron from the valence shell electron of the group 1 from the group 1 and the group number 2 elements. So the s block elements have the very low ionization energy. So the next point is they are electropositive in nature. Electropositive means electron, after losing electron, they acquires the positive charge. So they are electropositive element. So the elements which after losing, which have the ability to lose the electron, they are the electropositive. Why electropositive? Because after losing electrons, they acquire the positive charge. They will acquire the positive charge. So that's why we are calling them electropositive in nature. So all the s block elements, they are electropositive in nature because they have the tendency to lose the valence electron, because after losing valence electron, as we already explained, they acquire the group 18 like fulfilled stable configuration. So they are electropositive in nature. Next, they are reactive in nature. Reactivity means all elements are reactive. Only stable element group is the group number 18 because they have the fulfilled stable configuration. Exceptions are always present in the remaining element also, but the most stable group is the group number 18. Fine. So all other element except group number 18, they are not much stable. They have something reactivity, and they are reactive. And why they are reactive? Because they are not like that of the group number 18. So what they will do, they will want to achieve the group 18 like configuration. So to achieve the group 18 like configuration, they can lose the electron, they can gain the electron, they can share the electron. Means they will do anything like losing electron, gaining electron, or sharing the electron. So if after losing electron they get stabilized like group 18, so they are reactive. If they are stabilized after gaining electron, means they are also reactive. If they are sharing the electron, if two atoms are sharing the electron between each other, means they are also reactive because they are doing something. If the element is doing something, whether losing electron or gaining electron or the sharing electron with other atoms, means they all are reactive one. Means any atom, but there is one basic fact, okay, any alone atom can never lose the electron. Means there must be something, another atom which can gain the same number of the electrons. Means these two processes, that is the lose of electron and gain of electron, these two processes takes place simultaneously. These process never takes place alone. Now the question here is, that is the another thing, means these two processes takes place simultaneously. That is the basic fact. But why the s block elements are reactive? Because they have the valence shell electron. These valence electron can be lost easily, as we already discussed in the previous point. So they are reactive in nature. They can lose the electron easily to acquire the group 18 like fulfilled stable configuration. So they are reactive. They are ionic in nature. Why they are ionic in nature? Because they are group 1 element, group 1 and group 2, they are losing electron. So why they are losing electron? Because after losing they acquire the group 18 conjugation. And when they are losing electron, as I already told you, there is something another element which have the tendency to gain the electron. Means that another element, that another atom gaining the electron, means the other atom which gaining the electron acquire the negative charge, as these s block element after losing acquires the positive charge, as we call them as electropositive. Means after losing they are gaining positive charge, they are electropositive. And the other element which will gain these electrons, they will acquire the negative charge, so they are electronegative elements. So means when there is a something relation between the electropositive and the electronegative element, so that type of bonding between them is the ionic bond. So they are ionic in nature, they can form the ionic compounds. Means the extent of formation of the ionic bond is something else. These are the trend in the properties of these group number 1 or the group number 2 or the any other elements that we will discuss later on. Okay, which element have the more ionic character, which have the more covalent character, which these are the remaining properties which we will discuss after these points. Means they are ionic in nature. They are strong reducing agent. What are the reducing agent? The substance which have the tendency to lose the electron and get stabilized in the aqueous solution, so that called the reducing agent. The half definition is the element which have the tendency to lose the electron. That is not the complete one. That is not the complete definition. The complete definition is the element which have the tendency to lose the electron and get stabilized in the aqueous solution, called as the reducing agent. Means there are some element which have the large size, which have the tendency to lose the electron, but after losing electron, that large size of positive cation have not much tendency to get stabilized in the water. They have not much tendency to attract the water molecule around themselves. Means they have very less tendency to get stabilized. Means these such type of trend we will discuss in that S block element chapter. So the next property is they have the tendency to lose the electron. That is the basic fact, because after losing electron, one or the two electron, one for the group 1 and 2 electron for the group 2, they are going to stabilize like the group number 18 element. Means they have the tendency to lose the electron. But after losing that electron, whether they have the tendency less or more tendency, that is the another fact. But they have something tendency to get stabilized in the aqueous solution, so they are reducing agent. So group number 1 or group number 2 elements, they are reducing in nature, they are strong reducing agent. Next point is they are good conductor of heat and electricity. Any substance which have the free electrons, because the substance, the elements which have the tendency to lose the electron, after losing electron, if any of the element lose electron, so the remaining part after losing electron, that called as the kernel. So means these group 1 or the group 2 element, they are metals, because after losing electron, the remaining positive part, that kernel, and their lattice also contain the free electrons. So there is something attraction between that remaining positive kernel and the free electrons. So that attraction between the positive kernels and the free electron, that attraction is called as the metallic bond. And that is not the unidirectional, that is multidirectional, that is non-directional in nature. So that metallic bond is non-directional in nature, like the ionic bond we are just talking about in the previous point. Ionic bond means positive negative attraction between the positive and the negative ion. One positive ion is simultaneously being attracted in all the direction by different negative ions. Means that positive ion is not attracted only with one negative ion in one particular direction. Means that positive ion is attracted with many negative ion in the many direction, from right, left, up, down, and so on, from all the directions. So that is non-directional in nature. Ionic bond is non-directional in nature. Similarly, in case of S and P and other metals, that metallic bond is also non-directional in nature, because a particular kernel which is formed after losing valence electron, that kernel after losing kernel is losing that one electron, but there is another atom which is also losing one electron. Means there are many kernels in that lattice, there are many free electrons, and that one particular kernel is not being attracted by only that electron which is lost by that particular atom. Means after losing one electron, that particular kernel is simultaneously being attracted by the many free electrons which is present on the right or the left or upside or downside and so on by all these electrons. So the nature of that bond is also non-directional. So metallic bond is also non-directional in nature. And as there are free electron in the lattice of these S block and the P block and the other metals, so they are the good conductor of electricity. They are good conductor of electricity, heat and electricity. So the S block elements, because they have the free electron in their crystal lattice, so these free electron can move easily, so they are good conductor of heat and electricity. So S block elements are good conductor of heat and electricity. They can impart color in the flame. Why they can impart color in the flame? These group 1 element, as you can see in that diagram, because that valence electron is something attracted by that particular nucleus, and that particular attraction is not much strong, because after losing that particular electron, that atom becomes stabilized. But what happens here after gaining energy from the surrounding, because in the surrounding energy is present, but after gaining electron from the surrounding, that valence electron, that attraction becomes something weaker one, and that particular electron get excited, not lost completely, means something excited in the valence p subshell here. So means after excitation it becomes unstable. Means what I want to see here, okay, after absorbing energy from the surrounding, these valence electron get excited and become unstable. Means that 2s electron goes into the 2p. So when these excited unstable electron comes back in the ground state, when they come back in the ground state, जहां से गए थे वहीं पे वापस आ जाएं, then they will lose the energy in the surrounding. They will lose the energy in the surrounding in the visible region, so they impart color to the flame. Means if the energy is released in the visible region, then and only then we can say that particular compound is giving color. Means they imparts color in the flame. Means when you are taking that group 1 or the group 2 element or their compound on a spatula or in the platinum wire, or you burnt it in the flame, then what you will see there something color appears in the flame, reddish flame, greenish flame, that appears when you burnt S block element or their compound in the flame. Why that color appears in the flame? That is the question here. Means they impart color to the flame. Why they impart color to the flame? The reasoning is that after absorbing energy from the surrounding or from the flame, these valence electron get excited and become unstable. When these unstable electron comes back in the ground state, they release the energy in the visible region. ये लिखना जरूरी है. They release the energy in the visible region, so they give color to the compound. So they give color in the flame. So that's the next point. They are soft metal because, as we already learned, these valence electrons are not being strongly attracted by the nucleus. So due to the presence of that something weak attraction, means these electrons can be lost easily. Due to the presence of that weak attraction, these attraction can be easily been cut, easily been break by the knife. When we cut, for example, you can see in the laboratory when you are doing the organic analysis, during that you require the sodium metal which been placed in the kerosene oil, because they are very reactive, because they can lose the electron easily, they can easily catch the fire. So because of that reason, we kept these reactive metal in that particular liquid which cannot react with these group 1 element. For example, the kerosene cannot react with the sodium, so we can place the sodium in the kerosene oil. We can kept the sodium in the benzene, because benzene cannot react with the sodium. Means we have the requirement of such type of liquid in which we can in that liquid which can break the connection of these elements with the air or the moisture, and also this liquid must be non-reactive with that particular element. So whenever any examiner asks a question, okay, where we can kept these reactive metal, we can kept these reactive metal only those liquids which are non-reactive to these elements. which are non-reactive to these element, and these elements are, for example, generally you read in the books, we can kept the sodium or the group 1 group 2 elements in the kerosene oil, we can kept them in the sodium. Generally during the experimentation, during the research work, when we have the requirement of the sodium wire, we, with the help of the machine, when we kept the sodium in that particular machine and we move it, wire is formed of sodium, and we directly move that wire in the benzene. So which element can be used for drying of the benzene? Sodium wire. We pass the sodium wire in the benzene for drying of the benzene because of that particular region. So because there is something weak interaction, weak attraction between the valence electron and the nucleus, they can easily be cut. They can easily be cut. So they are soft metal. So group 1 and group 2 element, they are the soft metal. And due to the presence of these weak interaction, they have the low melting and the boiling point. So they are malleable, they are ductile, means as I already tell you, means they are malleable, they can be converted into sheet. They are ductile. Duct means wire, we can convert it into the wire, as we already told you that we can convert the sodium into a wire by passing it into the benzene for the drying of the benzene here. So they have the property of malleability and the ductility. Malleability means conversion of any of the substance into the sheet. That their property, if they have that particular property, they are malleable. If any of the element have the tendency to get so that they can be converted into the wires, so that their property called as the ductility, means they are ductile here. So means the S block elements, they are metals, they have the property to be converted into the sheets or the wires, so they are malleable and the ductile. They can form the basic oxide after reacting the S block element, because they are metal. So any of the metal, when they react with the oxygen, they form the oxide. And because they are reactive, as we already discussed, they are reactive elements. So they can react with oxygen, and after reacting with oxygen, they form the oxide. And these oxide are basic in nature. Because these oxide, when they are placed in water, they produce the hydroxide, means they can produce the OH negative ions. So according to the definition of the Arrhenius, any substance which can give OH negative ion in the aqueous solution are called as the base. They are the alkali metal. Group 1 element are called as the alkali metal because they can react with water to give the alkali, to give the hydroxide, which can easily give the OH negative ions. So they are basic in nature. So oxides of group 1 elements are basic in nature. Similarly, group 2 elements are called as the alkaline earth metal. Because their oxides are present in the earth crust, so they are called as alkaline earth metal because their oxides are present in the earth crust. So group 2 elements are called as the alkaline earth metal. So these are the general characteristics of the S block element. So any type of question can be asked like that we are discussing during that particular lecture. So you can see here the lithium, which is the group 1 element, can easily lost that 1 electron. When it reacts with water, what will happen? Water will give H positive and the OH negative ion. Now what will happen? That H positive ion will gain that particular electron to form the H, means half H2, as we shown here. And oxygen is a supporter of combustion and hydrogen is combustible, as large amount of energy is released during that particular process. So it can burn easily, means lithium, sodium, when they are placed in water, when we add water in it, they will produce fire. Means more energy means fire. If less energy is produced, there is no fire. When more energy is released, means something fire will produced. So when sodium is placed in the water, fire will produced. When sodium is placed in moist air, fire will produced, because sodium can react with water to produce the hydrogen gas, and hydrogen gas can be burnt easily. Oxygen is the supporter of combustion, and that is combustible gas. So oxygen present in the environment. So due to the release of large amount of energy, they catches a fire. So that is all about the characteristic of the S block element. So that's all about today's lecture. So you can You can learn all these points because any of the characteristic can be asked in the form of the question in your examination. Thank you for keeping patience. Thank you.